Hello everyone. Now let's look at a question from NCERT, inverse trigonometric functions, which reads, we have to show that left hand side is equal to right hand side. Sine inverse 8 by 17 plus sine inverse 3 by 5 equals tan inverse 77 by 36. Okay, even before we venture into this and then try solving it, first let's try to understand the basics behind it. How did somebody even come up with this equation? What exactly does it mean? Right? Let's not try to solve it mechanically using a particular method or technique. Let's try to understand what is behind this. If you look closely, each of the terms that we have would give us an angle. Let me call this as angle alpha, call this as angle beta, this angle to be gamma. Sine inverse of a value should give us an angle, sine inverse of of a value should give us an angle, tan inverse of a value should give us an angle. So basically, we are getting three angles if we convert each of those terms given there. So if I add alpha plus beta, I must be getting gamma. This is what they are looking for. And if I have a calculator, if you use a calculator which has inverse trigonometric functions in it, plug in the number now. There would be something called arc sine or directly sine inverse in that calculator. Plug in 8 by 17 or the equivalent of this in decimals. You would get 28.1 degree, or in radians this would read 0.49 radians. So that is the first term. Likewise, if you plug in sine inverse or arc sine 3 by 5, we end up getting 36.8 degree. The same thing in radians would be 0.64 radians. Go to tan inverse. So it is arc tan or tan inverse. On the calculator, if you plug in 77 by 36 or the equivalent in decimals, you end up getting this is equal to 64.9 degree, or in radians it is 1.13 radians. Let's try to correlate and then understand this. So sine inverse 8 by 17 is equal to 36.8 in degrees. Sine inverse 3 by 5 is, oh sorry, this should be 28.1 degrees, and sine inverse 3 by 5 is 36.8 degree, and tan inverse 77 by 36 is 64.9 degrees. And according to the equation, 28.1 degree plus 36.8 degree totals up to 64.9 degree, and that is what we have here, right, on the right hand side. So left hand side adds up to 64.9 degree, right hand side we have the exact same angle, and we can check that with the radians as well. 0.49 radians plus 0.64 radians should add up to 1.13 radians. So if we understand the basics behind it, we will understand how the equation is obtained and how we can prove would be the next step. Likewise, we will try to come up with or try to understand the equation itself. So now we have understood that two angles, when added or subtracted, we are getting another angle. For example, let's say I have pi by 3 plus pi by 6. Pi by 3 is 60 degrees, pi by 6 is 30 degrees. What would be the total? In terms of radians, it's going to be pi by 2, which is 90 degrees for me. Pi by 3 plus pi by 6, plain addition of these two would give us pi by 2. Can I represent this as an inverse trigonometric function? Pi by 3. How do I represent pi by 3? I can represent it in all the six inverse trigonometric functions. I can write it as sine inverse root 3 by 2. Shall I write pi by 6 also in terms of sine? Sine inverse? Yes, sine inverse 1 by 2, because sine inverse 1 by 2 takes us to 30 degrees, which is pi by 6. And pi by 2, to add some flavor, pi by 2 is cosine inverse 0. So the equation that gets generated is sine inverse root 3 by 2 plus sine inverse half equals cosine inverse 0. Let's look at other flavors. So I can write pi by 3 as cosine inverse 1 by 2. So pi by 3 can also be written as cosine inverse 1 by 2. And I can write this as cosine inverse root 3 by 2. Pi by 6 is cosine inverse root 3 by 2. And that is equal to cosine inverse 0. If I combine them and then write pi by 3 to be sine inverse root 3 by 2 from here, I'm taking each term and then writing the equivalent cosine inverse root 3 by 2 for pi by 6 and sine inverse pi by 2. Sine inverse 1 rather. Sine inverse 1 is equal to pi by 2, isn't it? So this is how the equations are formed. Equivalent of the angle in terms of inverse trigonometric functions should be written, and we would have plane addition of two angles leading to the third angle. Addition of two angles, pi by 3 plus pi by 6 is equal to pi by 2 is happening here. But to confuse us, or if we write the same thing in terms of inverse trigonometric function, it might look a little weird or little complicated. But all we are doing is two angles added and we are getting the third angle. Look at this. This can be rewritten as, okay, what is pi by 3? Tan inverse of root 3. Then pi by 6 is tan inverse of 1 by root 3. And sine inverse of 1. This becomes another equation. So everything is written in terms of inverse trigonometric function, and we get different kinds, different flavors for the exact same equation of pi by 3 plus pi by 6 is equal to pi by 2. We have formed four different versions. I mean, I can have many such expressions or equations by taking sine inverse, cos inverse, tan inverse, cot inverse, secant inverse, cosecant inverse. I can come up with many flavors of this particular equation. Hope you got an idea on how exactly we are getting the equations that need to be proved. So going back to what is given in the question now. Let's take this up and try to solve. So it says sine inverse 8 by 17 plus sine inverse 3 by 5 equals tan inverse 77 by 36. Every time you see such kind of equations, you should remember this is representing an angle, this is representing an angle, this is representing an angle. That's all. Sum of two angles is equal to third angle, and we also saw what the values are. We will try to solve it using the inverse trigonometric functions properties. So this is alpha, this is an angle beta, this is angle gamma. We know the exact angles if we use the calculator, but without calculator, how do we solve it? And then show left hand side turns out to be what is there on the right hand side. So I will consider sine inverse 8 by 17 to be alpha. Taking sine function on both sides, we end up getting 8 by 17. Sine inverse would work as identity function. So this becomes sine alpha. 8 by 17 is equal to sine alpha. Likewise, if I take sine inverse 3 by 5 equals beta, 3 by 5 would be equal to sine beta. We'll wait. We won't do anything with the right hand side. We will try to get to the right hand side using the left hand side. All right. So let's try to find out cos alpha. Cos alpha we all know is 1 minus sine square alpha. Plug in the value 1 minus 8 by 17 whole square cos alpha, and we know this is 289 minus 64 divided by 17 square, 225. 17 square, that is equal to 15 by 17. That is cosine alpha for us. Or else if you had realized 8, 17 and Pythagorean triplet would give us 15 there. So 15 by 17 would be our cosine alpha. Similarly, let's try to find out cosine beta. Cosine beta is equal to 1 minus sine square beta. Respective angles should be considered there. 1 minus 3 by 4 whole square, or that would lead us to 3 by 5 rather. That would lead us to 4 by 5. Cosine beta would be 4 by 5. Cosine alpha is 15 by 17. So what are we supposed to find out? We are supposed to show alpha plus beta is equal to gamma, and in place of gamma we have, okay, there's a glitch there. Let's take tan inverse 77 by 36. Agreed? Look at this, alpha plus beta should be equal to gamma. Gamma is nothing but tan inverse of 77 by 36. What if I just consider alpha plus beta and then take tan of alpha plus beta? Let's plainly take alpha plus beta. Alpha is an angle, beta is an angle. I'll take tan of alpha plus beta. If I had to write the expansion of this turns out to be tan alpha plus tan beta divided by 1 minus tan alpha tan beta. Do we know tan alpha information? No, we don't have it directly, but we can definitely figure that out. Sin alpha is 8 by 17, cos alpha is 15 by 17. What is going to be tan alpha? Where do I write it? I can write this as sin alpha by cos alpha, or else I can calculate it outside, plus sin beta and cos beta divided by 1 minus sin alpha by cos alpha sin beta by, it might look as if I have complicated it. So if you want, you can try sin alpha by cos alpha and find out the value, come back and then just plug in the value. So when you plug this in, we get 8 by 17 divided by 15 by 17, which is 8 by 15. Sin beta by cos beta would give us 3 by 4. 1 minus 8 by 15 into 3 by 4. If you observe and simplify this, this gives us 77 by 36. Tan of alpha plus beta is giving us 77 by 36. What is alpha plus beta going to be? It is going to be tan inverse of 77 by 36. If you take tan inverse function on both sides, tan inverse of tan, it would work as identity function. So alpha plus beta would be the result. Right hand side becomes tan inverse 77 by 36, and that's how you end up getting alpha plus beta is equal to tan inverse 77 by 36. And that is what we were trying to find out, right? And hope you have understood why or how we get the required equation in the first place. Two angles added up to give the third angle. Then we can represent each of the angles in any of the inverse trigonometric functions. So in this case, they have taken sine inverse for alpha and beta, and then for gamma they have used tan inverse. So we can represent in any of the 6 trigonometric inverse functions, and we will continue based on what is there on the left hand side, based on and then what we have to get to on the right hand side. We will decide once we have alpha plus beta is equal to gamma identified, depending on right hand side, if it is tan inverse that we have to get to, so we will take tan on both sides, or tan on alpha plus beta, expand it, replace the values, and then figure out the equivalent of it, take tan inverse on both sides, you end up getting the required right hand side result. Hope it makes sense. Thank you.